So now we're going to discuss data visualization for distribution. And for distribution, there are two types, histogram and KDE plot. So we want to use this flower data. We will first read CSV and print the first 5 rows of the data. And we can see that uh, this data has sepal length, sepal width, petal length, petal width, species. And for histogram, you can use this to see how petal length varies in iris flowers. So we can do this with the Seaborn histplot command. And in the code cell above, we had to supply the command with the column we'd like to plot. In this case, we chose petal length in centimeter, and we were able to see histogram of all petal length in the iris data. Now let's look at KDE plot. KDE plot is kernel density estimate plot. It is a type of graph that uses a kernel density estimate to show the probability density function of a continuous random variable. So KDE plots are used to represent the distribution of a variable. In that sense, it's similar to a histogram, but the difference is, unlike histogram, KDE plots provide a smooth curve that approximates the shape of the distribution. So some of the components of the KDE plots are x-axis and y-axis, and x-axis represents the values of the variable being plotted, while the y-axis represent the density of the values. So the KDE plot is a smooth curve that shows the distribution of the variable. And there are several types of KDE plots, including like a univariate KDE plots and bivariate KDE plot. So what univariate KDE plot does is it shows the distribution of a single variable, while the bivariate KDE plot shows the joint distribution of two variables. So in order to make this, you need to use sns.kde plot and then provide data. And then if you set shade to be true, the colors of the area below the curve it will be shaded. So two-dimensional KDE plot, in order to create this, you can call SNS joint plot command. Then you can provide X and Y and provide kind. For X, for this demonstration, we will use petal length, and for Y, we'll use sepal length, sepal width. So you can see the curve at the top of the figure is for the data on the x-axis, and the curve on the right of the figure is the KDE plot for the data on the y-axis. For this case, is a sepal width, and in order, if we want to show 2D KDE plot, we will see something looking like this. And we can create plots to understand differences between the species. To do that, we can create 3 different histograms, one for each species of petal length by using the SNS histplat command. And I guess additional thing that we're providing is hue. By providing this, we can set the column to split the data into different histograms. And when we create this, it will look something like this. So Iris setosa has blue color, and Iris versicolor has orange color, and Iris virginica has green, and some of the area that intersects will have a different color. We can also create a KDE plot for each species by calling SNS KDE plot. So the functionality for data X and hue are identical to using SNS histplot. Additionally, we can set shade to be true to color the area below the curve. When we do that, it will look, we will have a more smooth curve looking like this. So what pattern do you see? The interesting pattern that can be seen in these plots is that the plants seem to belong to one of 2 groups, where Iris versicolor and Iris virginica seem to have similar values for petal length, while Iris setosa belongs in a category all by itself. In fact, according to this data set, we might be able to classify any iris plant as Iris setosa just by looking at the petal length. If the petal length of an iris flower is less than 2 centimeters, it's most likely to be Iris setosa. So in summary, we looked at the distribution to show the possible values that we can expect to see in a variable, along with how likely they are. And 2 of them are histograms and KD plots. And histogram shows a distribution of a single numerical variable, and KD plot shows an estimated smooth distribution of a single numerical variable. And we also looked at 2D KD plot. What this does is it simultaneously display 2D KD plot with the corresponding KD plots for each individual variables. That's everything for distribution. Thank you, everyone.